Alright, hello everyone. My name is Eric, and today I'll be teaching the physics concept of torque. Torque is the turning effect of a force and explains why some objects are easier to rotate than others. In this lesson, I'll explain what torque is, how it works, apply it to solve a physics problem, and finish with some everyday examples of where torque is used. So let's get started. Alright, so imagine you're changing a flat tire. You grab the short wrench that came with your car and pull as hard as you can, but the lug nut won't move. As you can see here, a short tool that's being used. Alright, now imagine someone hands you a much longer breaker bar. You pull with about the same amount of force, and suddenly the lug nut comes loose much more easily. As you can see, it's a longer bar, right? But if you're using nearly the same amount of strength, why does the longer tool work so much better? The answer to that is torque. So what is torque, you might be asking? Torque is the turning effect of a force acting on an object around a pivot point or axis. The amount of torque depends on three things: the applied force, the distance from the pivot point to where the force is applied, which is called the lever arm, and the angle between the applied force and the lever arm. The further away you apply the force from the pivot, the greater the torque that is produced. So here's the equation for torque. The variable T represents torque and is measured in Newton meters. The variable R represents the lever arm, or the perpendicular distance from the pivot to where the force is applied, and is measured in meters. The variable F represents the applied force and is measured in newtons. The variable theta represents the angle between the force and the lever arm and is measured in degrees or radians. So the reason I have the wrench back here, looking back at the wrench example, both people applied the same amount of force. The difference was that the breaker bar had a longer lever arm. Since the distance from the pivot increased, the torque also increased, making it much easier to loosen the lug nut. Okay, here I'll apply the concept of torque to solve a physics problem. So the problem states that two children are hanging from the same tree branch. One child has a mass of 38 kilograms and is hanging 1.40 meters from the tree trunk. The second child has a mass of 27 kilograms and is hanging 2.55 meters from the tree trunk. The branch is angled 27 degrees above the horizontal, and we're asked to find the magnitude of the net torque exerted on the branch. First, what I'm going to do is define the variables for this question. Variable TAU represents torque and is measured in Newton meters. The variable R represents the distance from the pivot point to where each child is hanging and is measured in meters. The variable F represents the force due to each child's weight and is measured in newtons. The variable theta represents the angle between the branch and the downward force of gravity. And before calculating torque, I first need to determine each child's weight using the equation F equals mg, where m is the mass in kilograms and g is the acceleration due to gravity, which is 9.81 meters per second squared. And for the first child, F equals 38.0. I had written all this down to make it easier to explain. Let me get out of this mode right here to show what I'm talking about. Okay, for the first equation right here, that's for the first child. And this is for the second child right here. And since the branch is 27 degrees above the horizontal, the angle between the branch and the downward weight force is 63. And now I use the torque equation. For the first child, It would be this one right here. Oh, I don't like how that came out. That's better. And for the second child, it was right here. And after rounding to wait, no, I forgot this one right here. Both torques act in the same rotational direction, so I added them together right here. And after rounding to 3 significant figures, the answer is 1066 Newton meters. And that's exactly what I got down here. Okay. So this is the part where I talk about torque being used in everyday situations. For example, opening a door, twisting a bottle cap. I don't have pictures here, but what else? Pedaling a bicycle. I remember a baseball bat question. So swinging a baseball bat, like I had done in a previous homework problem, or using a crowbar, and like I just showed, tightening or loosening bolts with a wrench. They all rely on torque. I forgot to highlight that one. So in every example, increasing the applied force or increasing the distance from the pivot increases the amount of torque that is produced. Today we learned that torque is the turning effect of a force, that it depends on force, distance, and angle, and that understanding torque helps explain why longer tools make difficult jobs much easier. That is it for today, and thank you for watching.